So we are moving forward with MENOG plenary session until lunchtime, which consists of 3 presentations and peering personals. So please allow me to invite Job Snijders from NTT to stage for his presentation about routing security updates.
Good morning, MENOG. It's still morning. My name is Job Snijders. I work for NTT Communications, a global IP transit provider. And it's really a pleasure to be here today. The last time I was in Lebanon was about 6.5 years ago. And the moment I noticed the next MENOG would be in Lebanon, I was like, I will be there. So thanks for having me. Let me try and figure out how this works. How do I get a preview on the... Nope. You'd think that after all these years with computers, I'd have a grasp on how these things work. Oh, there we go. So today I would like to talk with you about an update on routing security developments. What I want to share with you is developments from other parts of the world and how those developments may impact you or not impact you, and what you specifically can do to protect yourself against routing incidents. So why are we doing any of this? I think there are 3 reasons why routing security matters. Routing security, in principle, requires you to carefully administrate your routing intentions so that others can build filters. And this administration provides an auditability aspect, a trail, so to speak. This makes it harder for people to forge things. Secondly, we may suffer from software defects. I personally had a situation where on a specific high-end router, the software stopped adhering to the configuration, so the router was pretending to me as operator, yeah, sure, I applied your changes, but in reality the router was doing something entirely different. And the only way this could be remedied at that very moment is that you depend on the filters your neighbor has installed for you. And then third, mistakes happen. On my keyboard, the keys 4 and 5 are really close to each other. It's very easy to misenter an IP prefix. And for this reason, routing security is very useful because it protects you and me against mistakes I might make when I'm typing on my keyboard. The average view on routing security over the last decade has been pretty dim. Many people in the industry sort of gave up on routing security. They pretend that it's useless to invest any time in routing security because there's so many problems and so many holes in the ecosystem. But I think that's not entirely true. There is a finite amount of issues related to routing security, and this means that if we take those hurdles one by one, eventually we'll end up in a situation where it is much, much harder to suffer from the negative effects of misconfigurations or BGP hijacks. In other words, I think there is hope. I made a list of problems in the routing security space, and I will go over the problem space one by one in this presentation, offer you problem statements itself and proposed solutions. The problems boil down to inaccurate IRR databases, lack of filtering at internet exchanges, lack of path validation in context of BGP security, and then finally the lack of software. And on all these fronts, I have good news for you. So let's go over IRR. At this moment in time, there are 10 or 11 IRR databases that do not validate whether the creator of a route object actually is the same entity as the owner of a prefix. In other words, a lot of these databases allow you to register IP space that does not belong to you. And again, this may lead to issues because either of typos, where people misenter the prefix information, or for adversarial reasons, where an IRR registration is used to facilitate a BGP-based attack. So out of the databases that are not doing any validation, prominent databases are NTTcom's database or RADB, and in the past, RIPE even was one of them. There is two solutions to unvalidated databases. One is where you lock down the database, and one is a different approach that I'll highlight in the upcoming slides. Let's zoom in on the RIPE situation. Up until last year, it was possible to register non-RIPE managed space in the RIPE database. In other words, if you would register RIPE managed space, it would carefully conform to the consent of the prefix owner, but you could also register ARIN or APNIC or FRINIC space, and then anything would go. And this was identified by the community as a security hole, and the database working group came up with a proposal together with RIPE NCC staff to address this issue. So what happened is that you can no longer register non-RIPE space in the RIPE database, which I think is a great step forward. And this also means that you can no longer register space belonging to entities in different regions. Furthermore, the creation of route objects was simplified. You no longer need the consent of the ASN that is listed in the origin attribute. And this brings RIPE route registrations very much in line with RPKI registrations. In other words, that one is solved. Now we have 10 other databases to go. Let's zoom in on the ARIN IRR. ARIN has a IRR service that adheres to very different rules than the RIPE database. You may ask yourself, how does this affect me? What do I care about the ARIN database? That's on the other side of the world. The issue with this type of database is that fraudulent registrations in that database may negatively impact your prefixes. So for instance, the example you see on the screen is a route object that covers my personal RIPE IPv6 prefix, but the route object was not created with my permission. And this means that your prefixes may also be registered in the ARIN database, and there's not much you can do about that other than reach out to ARIN and complain. So this is a security issue. Luckily, the ARIN community also identified this as an issue, and the community tasked the ARIN organization to come up with a better IRR service where they either validate against the owner of a prefix or just kill the service altogether. Either outcome is fine with me because both outcomes address the security issue. Right, now we tackled 2 out of the 11 IRR databases. We can keep going all day trying to address each of these databases one by one, but I would argue a bigger hammer is needed. So what I propose to you is that we can use RPKI data to clean up fraudulent or still or outdated IRR information. Let's go over how this works. If we look at the IRR ecosystem, a poorly understood aspect of how IRR data is consumed is that even though there are many IRR databases, most software only uses 2 entry points into the IRR ecosystem when it comes to sending queries to generate prefix filters. One is whois.radb.net, and the other one is rr.ntt.net, which is under administration of the team I work in. And basically all mirroring is done to these 2 services, and from there the information is redistributed. So this is a schematic overview. On the left side you see the various IRR databases, including RADB and NTTcom themselves. Then in the middle are what I call aggregators. These are servers that collect all the database information, reshuffle the database information into a format that is quick to query and access. And then on the far right side, you see clients, and these clients talk to the aggregators. They don't talk to the databases directly. So what we can do is we can use RPKI information to drown out conflicting IR information. Some of you may be aware of how RPKI works and how origin validation works. In short, origin validation normally is applied to BGP updates, where a BGP update comes in, you compare it against your local RPKI cache, and then either invalid, valid, or unknown states come out of that process. And because a BGP update and a route object are so similar, both have a prefix length, and an origin ASN, I posit that we can use not just BGP updates as input into the origin validation procedure, but you can also apply this procedure to IR information. And if we apply this procedure to IR updates, what we conceptually have is a firewall between the aggregators and the sources of IR information that can potentially contain unvalidated or outdated or malicious data. And as an end result of applying this firewall thing at the aggregator level, the clients will no longer be able to receive fraudulent information. In other words, we don't need to do any software. I'll summarize this slide in a few sentences. What it boils down to is that IRR information, in principle, cannot be used to generate filters to apply to your upstream eBGP sessions. But with RPKI, the semantics and the meaning of the objects is slightly different, and this allows us to use RPKI data on any type of BGP session, be it customer-facing, peering-facing, or upstream-facing. And because of this property, we can also use RPKI data in context of IRR. There are two main benefits to this approach. Benefit one is that it cleans up the past. Right now, it is pretty hard to get IR information removed from various IR databases. Not all databases operate on a 24/7 support basis. Not all databases have the same rules or policies when it comes to when they will remove incorrect IR information. If we use this mechanism, all of the past IR route objects that were created in the last 20 years can be scrubbed and cleaned up. But it also helps protect you going forward. Because the moment you put RPKI ROAS into RIPE NCC's management portal, the IRR daemons, or the aggregators that I mentioned before, have information about what route objects to accept and which ones not to accept. So if you create RPKI ROAS, and the aggregators have been updated to have this trick up their sleeve, it means that it will be incredibly hard to create route objects that conflict with your published routing intentions. In other words, we're cleaning up the past, and we add a layer of protection going forward. I think these are two very significant benefits other than using RPKI in BGP context. And with that, I consider the problem of unvalidated IRR databases mostly a problem of the past as we start infusing this data with RPKI data. We're making actual progress to get to this point. NTT and Dashcare are working on a new version of the IRR daemon that will be operated on the two endpoints, whois.rdb.net and rr.ntt.net, and that will have these protections built in. You can follow our progress on GitHub. Another aspect that has come up often in routing security context is that there was a lack of filtering at route servers. I'm very happy to state that in 2019, the situation is much, much different than it was 2 years ago. We are currently at the stage where 9 out of the 10 largest IXPs are filtering on their route servers. And some of them are even doing RPKI origin validation on their route servers. And if 9 out of the 10 largest IXPs can do it, any IXP can do it, regardless of size. There is excellent open source software available these days in the form of a route server or IXP manager. Both of these open source packages can generate secure route servers. And if you're an IXP operator with a route server functionality, I would implore you to take a look at one of these 2 open source software projects to improve the quality and reliability of your route servers. Another weird thing to say as an RPKI proponent is that maybe not everybody needs to do RPKI. If we look at today's internet ecosystem, there has been extreme consolidation at the core of the internet. And with core of the internet, I'm no longer referring to transit-free large transit networks, but I'm referring to the large cloud providers. For instance, both Google, Amazon, and Cloudflare host an incredible amount of authoritative DNS services. Cloudflare and Google even have a public DNS resolver service. And this means that if these 3 networks would do RPKI origin validation and create ROAS for their respective prefixes, they are creating secure paths back and forth because they're peering directly with each other. And this means that billions of end users positively benefit from the actions of just a select few large companies. In other words, if the top 20 companies relevant to the internet would deploy RPKI origin validation, we will already see a very different internet landscape compared to where we are today. Some have argued that BGP origin validation is worthless without path validation. And then initially, I too thought that this would be the case because how can we trust anything if we don't have a secure path? I have good news, however. This is a graph of the average AS path length observed by the RIPE-RIS BGP collectors. And what you're seeing in this graph is that for more than 10 years, the average path is relatively stable. It hovers around 4-ish. However, at the same time, the default free zone keeps growing. We're now at 67 or 68,000 autonomous systems in the default free zone. So the only conclusion that we can draw from this graph remaining pretty flat, even though the default free zone is becoming larger and larger, is that we keep connecting directly with each other. For some reason, internet operators consistently seek out to connect more densely, connect more directly with each other. Let's go over some examples in a directly peered or transit scenario and why RPKI origin validation and path validation may not be entirely necessary. So in the upper right, you see Google. They announce a /23 prefix. In the bottom right, you see a adversarial element, an attacker. And in the middle, we have some transit providers. On the far right, we have Cloudflare. If we look at, far left, sorry. If we look at the paths available to Cloudflare, we see a /23 via 2 paths, 2 of the intermediate networks. And at the bottom, you see a /24 that is the rogue announcement from this attacker. And Cloudflare will select the /24 because it's the most specific route, and in internet routing, most specific routes usually win. The same scenario applies in a directly peered scenario. Via an internet exchange, Cloudflare receives multiple paths, some /23s that are legit, the /24 which is not legit, and it will send traffic to the wrong endpoint. Now, we enter RPKI into this mix. As it happens to be, Google created a RPKI ROA covering that /23, and in their ROA, they have stated that the maximum length that is permissible is a /23. So we go back to our attack scenario, and the /24 announcement from the attacker is no longer accepted because Cloudflare is applying origin validation rules, and they suppress the /24 because it's invalid. They'll continue to accept the legitimate /23s. The attacker thinks, oh, this is interesting. My /24 is no longer accepted because the prefix length is incorrect. The attacker starts announcing a /23. But what happens now is that the attacker's ASN is not the correct ASN from the ROA perspective. So that announcement is also rejected because it doesn't violate the prefix length, but it violates the origin ASN. The attacker grows up and learns more about RPKI and internet routing, so they decide to spoof the origin ASN. They forge a BGP announcement that has the /23 route that was permitted by the ROA. They spoof the origin ASN that was permitted by the ROA. But now we have a very interesting situation. Even though from an RPKI perspective, the spoofed announcement is permissible, what you now see is that the AS path from the attacker is longer than the AS path to the legitimate destination. So because Google and Cloudflare have a direct BGP session with each other and a short AS path of just one hop, the attacker is still not able to insert themselves between Google and Cloudflare because their AS path is longer and there is no way around this. In other words, when you combine origin validation with direct peering with each other, and you ensure that the direct peering has short AS paths, there's an actual security advantage to peering with each other than the economic benefits of cutting out the middleman. So origin validation is extremely powerful even without formal path validation, as long as we peer directly with each other, which coincidentally is something our industry has been doing for decades. So path validation solved. Next topic, software. In recent years, at times, the situation for reliable software in the RPKI ecosystem was not optimal. Not always was there sufficient choice for operators what software to use. But anno 2019, I am very optimistic about the situation because if you look at a software ecosystem, you take the long view, you look at 10, 20 years of software, if you want there to be two excellent choices for the network operator, you need 3 or 4 or 5 software implementations that are competing with each other. Not competing for market, but for quality or features. And each of you, when you're deploying RPKI, should rely on not just one implementation, but you should at least have another implementation lined up to ensure operational reliability. And I would like to highlight that in this day and age, there now is the Routinator software from NLNet Labs, which is shaping up to be a very high quality, promising software. And the OpenBSD community is also working on a RPKI cache validator implementation that will be available soon. And just a few weeks ago, Cloudflare released a RPKI cache validator that they're using internally. So with these new tools coming into the ecosystem, it is that with greater confidence I can encourage you to deploy RPKI origin validation. If one of these implementations runs out of funding or the developers get distracted and are diverting their attention to other projects, we will still have sufficient choices in the ecosystem. And then on the router vendor side, Nokia, Cisco, Juniper, Beirut, OpenBGPD, there's lots of vendors, high quality vendors that have implemented origin validation and have done so a number of years ago. This means that if you deploy origin validation in this day and age, you are not the first to do so, decreasing the chances of hitting bugs. So the healthy ecosystem in 2019, I'd argue, solved. As a side note to all of these, some of you may be wondering, all right, origin validation, RPKI, you got me sold. What will it mean for my network? To this effect, my colleague Paolo Lucenti and I, we work together on PMACCT. This is a traffic analyzer engine that some of you may be familiar with. What PMACCT originally did was it had a capability to ingest BGP feeds from your edge routers. It could also ingest S-flow, NetFlow, or IPFix data. It would correlate the two, and this correlation process is called aggregation. And this aggregation step would allow you to very carefully analyze the profitability of your network. How much traffic is flowing from customer to customer? How much traffic is flowing from upstream providers to my customers or from peering partners to my customers? Which of the peering partners or potential peering partners should I reach out to because there is economic incentive to set up direct peering? PMACCT was great for this type of question. And what we did is we added a origin validation capability in the PMACCT engine. And this means you are now in a position to predict what will happen when you deploy RPKI origin validation without deploying RPKI origin validation. You don't even need to change anything in your network because the origin validation procedure is done inside the traffic analyzer engine and not on your border routers. Version 1.7.3 has this capability. It's very new, it's only a few weeks old, so please check it out. To put it in context of what this means in NTT's network, this is a graph of our global backbone. I cannot disclose the actual traffic figures, but I can give you a sense of the size of things. Blue represents traffic we are sending towards destinations that are not covered by RPKI ROAS. The yellow, which is between 10 and 15%, is traffic that is destined towards RPKI valid destinations. So this means that from a business perspective, we already have an incredible amount of customers that went through the effort to create RPKI ROAS to protect their online assets. Then you see a sliver of purple-ish. These are RPKI invalid announcements that are covered by a less specific, valid, or unknown announcements. In other words, these are misconfigurations in the RPKI infrastructure, in the RPKI database, but they will not have effect to our business because we still have alternative, acceptable, less specific paths. What I see quite often is that people put in a ROA for, say, a /16. A year later, they de-aggregate their /16 for traffic engineering reasons, and they did not create RPKI ROAS for those more specifics that exist for traffic engineering reasons. So it is natural to see lots of RPKI invalids in the default-free zone, and it is important to understand which of these invalids have an impact on business and which of these invalids can safely be ignored. And then the top green, which is 1 pixel, and the graph could not make it smaller without not showing it at all. Those are invalid announcements without alternative paths. So these are misconfigurations where somebody somewhere did not create the RPKI ROAS in an appropriate manner. And the point of this graph is that the amount of traffic flowing towards such destinations from a statistical perspective is absolutely irrelevant to our bottom line. We can safely drop RPKI invalids. We would lose routes to roughly 1,000 prefixes or so, but those prefixes do not represent a measurable amount of traffic on our network. And this is confirmed by, for instance, AT&T, who deployed RPKI origin validation a few weeks ago, and many other deployments that I've seen. In other words, it is feasible from both a commercial and an operational perspective to reject RPKI invalid announcements. But you can verify this for your own network if you install PMACCT. So the timeline I would propose to you. if you're an ISP, if you have IP address blocks, log into the right portal and create RPKI ROAS for your prefixes. Even if you don't intend to deploy origin validation anytime soon, by creating RPKI ROAS, you facilitate me as an internet backbone or IXP route servers to protect your interests better. And this applies not just to the BGP routing tables, this also applies to the IRR cleanup that I mentioned earlier. So it is very attractive in my opinion. There's a lot of benefits to creating RPKI ROAS for your prefixes. If you're an internet exchange point, deploy origin validation on your route servers. I can help you do so. There's excellent open source software to do so. As an IXP, you never represent a full routing table anyway. You have no obligation to carry all routes that are learned. So it is in the best interest of your participants if you deliver the highest quality possible BGP feed to the participants. As a route server becomes more secure, its value to the participants increases accordingly. Later in 2019, I hope that we can launch the RPKI cleanup trick to scrub the IR. We're developing the software as we speak, so stay tuned. And hopefully later this year, the ERIN RPKI TEL situation improves. As it happens, there are 5 RERs, 4 of them have made their public keys publicly available, and 1 of them has not done that. Luckily, we are now in the RIPE region, and RIPE has freely distributed its RPKI keys, so this is less relevant to this audience. Small update on deployment. Cloudflare and YYCIX, Canadian-based internet exchange, deployed origin validation in the last few months. Great news. And then much bigger networks also started joining this momentum. So AT&T now rejects invalids on its peering sessions. Nordunet, the North European National Research Network, rejects invalids. KPN, the Dutch incumbent, is rejecting invalids on a large number of eBGP sessions. And the list goes on and on. Every week there is some network somewhere that is deploying origin validation and being public about it. And this shows that if you're considering this, you are in excellent company. All of these are reputable names, and if they can do it, it should be good inspiration that it's possible for you too. So, in other words, I think routing security in 2019 and 2020 is actually looking up. There's lots of good news. There's many great initiatives in the pipeline. Routing security is now being taken serious by multi-billion companies. That's always a good sign. So I'm optimistic, and I hope you can share my optimism and create ROAS and deploy origin validation in your own networks. With that, I would like to open up the microphones for questions, comments, concerns, or if you don't want to talk to the microphone, feel free to email me at job@ntt.net for any specific questions. I'm not sure the microphone is done. Can you try the one behind you? Yes, that one works.
Salam Yamut Internet Society. Thank you very much, Job, for this very interesting presentation. For those of you who don't know Job, he is like a pioneer in RPKI and routing security in the whole world. And his work is really commendable. My question to you, Job, is yes, we agree that RPKI validation and all ISPs should create their RPKI ROAS, and we should be doing this. But is this enough to secure the internet routing? Shouldn't we also be doing filtering, for example, and the other actions that the Manners initiative calls for?
That's an excellent question. I have to admit that the scope of this presentation is purely routing security, and I'm not looking at any other security issues that may be present in computer networks. And if we look at the things we can do, yes, I think creating ROAS for now is sufficient. For any routing security to exist, the first step forward is that we have a cryptographically verifiable, programmatically available index of which prefix belongs with which ASM. If that foundational aspect is not yet present, then any further steps cannot be taken because it's such a critical building stone. So create ROAS, and maybe 2 or 3 years from now we'll extend RPKI with other technologies to improve other issues in routing and computer security. But for now, this is the absolutely first elementary step. Without RPKI ROAS, no other routing security improvements can be made. Any other questions or comments?
Hi, I'm Aftab Siddiqui. So just wanted to highlight one thing that you mentioned, that ROAs are very important. Looking at the statistics, the ROA uptake from region is very low. So I would encourage people to sign their ROAs. Right now, the staff is here to help them out. I'm confident about that one. And if you are here and you have the access to your LIR portal, and if you sign your ROAs here, come and collect a T-shirt from the Internet Society booth.
Thank you. Not sure it's working.
Can you hear me now? Yes, test. Okay, it's working now. So I've got a question from the remote hub in Yemen. So regarding RPKI and ROAS, what will happen if we don't apply RPKI and create ROAS? Is there going to be any drop of our legitimate ASNs?
Great question. The way I interpret the question is, what happens if I don't create ROAS?
I think yes.
And the beauty of all of this RPKI stuff, all the protection layers, the effects it will have on direct peering or IRR, all of this is opt-in. If you don't create RPKI ROAS, you are as good or as bad off as you are today without having created them. So all of this, it's an opt-in mechanism. You choose whether you want to add that additional layer of protection to your online assets or not. The choice is yours. Nobody is forcing you. I am merely advocating that you should create ROAS. But if for whatever reason you don't want to or cannot create RPKI ROAS, then nothing changes for you. However, you will still benefit from other people creating ROAS because the internet is two-way communication. There is your network and you're communicating and exchanging data with some other network. And if that other network is better protected by the intermediate operators such as transit networks or internet exchange route server operators, you will still benefit from the increased chance of delivering the traffic to the correct endpoint. So if you don't want to create ROAS, that's fine, but I think there are a lot of benefits to it.
Thank you.
Hello, thank you. My question is that there are some cloud providers that provide DDoS protection, okay, using BGP. When we have a volumetric DDoS attack, the traffic will be rerouted, and you know the rest of the story. So if this provider will implement RPKI, does this affect the way it provides DDoS protection?
Another great question. What is the effect of RPKI origin validation in context of DDoS mitigators? There are two methods to do DDoS mitigation. There is the in-network method, which NTT applies, where the outside world does not see that we're rerouting traffic through scrubbers and then delivering clean traffic to the customer. There's also the out-of-network or off-path DDoS mitigation approach, where the DDoS mitigator will announce /24 announcements, which is the most specific announcement that will propagate in the default free zone, to steal all the traffic, all the DDoS traffic coming to the endpoint, and then scrub the traffic and deliver the clean traffic via a GRE tunnel back to the customer. And the curious thing here is that what these DDoS mitigators that are doing off-path scrubbing, essentially these are BGP hijacks from a technical perspective. Because the customer may have a /16 that's being announced over here, and the DDoS mitigator starts announcing a /24 over there. And as a network operator in the middle, I cannot differentiate between BGP hijacks as a result of misconfigurations or BGP hijacks that are for the good of that endpoint. And the trick here is that if you set up a relation with a DDoS mitigator, that ahead of time, you must authorize that DDoS mitigator to announce IP space on your behalf. So it is of paramount importance that ahead of time you practice the scenario with the DDoS mitigator, use a prefix that you're not using for testing purposes, and ensure that throughout the simulation or the exercise that you verify in looking glasses whether the DDoS mitigator is adhering to the RPKI ROAS that you created, or that additional ROAS need to be created to authorize the DDoS mitigator. So the key is, if you're under attack and you call a DDoS mitigator and you tell them, start scrubbing right now, then you're too late. Ahead of time, so this means at least say 24 hours ahead of time, create the appropriate route objects, the appropriate RPKI ROAS, and this will allow the DDoS mitigator to announce /24 routes on your behalf. In the RPKI publication mechanism, it takes a few hours, between 6 and 24 hours, for information to percolate to the far corners of the ecosystem. This is similar to IRR information, where it usually takes 24 hours for upstream providers to include new information in their prefix filters. With RPKI, the reasoning is similar. So prepare ahead of time, and then there will be no issues. Feel free to email me. Thank you for your time. Have a good day.